Hello everyone, welcome back to our YouTube channel. So today we are going to study about the hierarchical clustering algorithm. So first we will understand what is hierarchical clustering. So hierarchical clustering is a unsupervised machine learning algorithm that is used to solve the clustering problem similarly like k-means and k-medians. This algorithm groups the unlabeled data sets into the clusters. So hierarchical clustering is also known as hierarchical cluster analysis or HCA. So in hierarchical clustering we develop the hierarchy of clusters in the form of tree, and this tree shaped structure is known as dendrograms. So sometimes the results of your k-means clustering and hierarchical clustering may look similar, but they differ on depending upon how they work. As we have seen in k-means clustering, we need to predetermine the number of clusters before starting with the algorithm, but in hierarchical clustering there is no need to predetermine the number of clusters. So why we are using hierarchical clustering? So as we there are many challenges regarding the k-means clustering. So to overcome these challenges or to solve these challenges, we use hierarchical clustering. So some of the challenges of k-means clustering are: first one is to predetermine the number of clusters, as I have told earlier. Second, it always tries to create the clusters of same size. So these are the some challenges regarding the k-means clustering. So we use hierarchical clustering. So now we will see what is agglomerative hierarchical clustering approach. So this is one of the popular application of hierarchical clustering algorithm. So what does agglomerative hierarchical clustering approach does? It just groups the data set into clusters in the bottom up approach. So this algorithm considers each dataset as a single cluster at the beginning and then starts combining the closest pair of the clusters together. So what does this mean? Suppose we have a data set in which there are 6 data points present. So what this approach will do, it will consider each of the data point from the data set as a single cluster at the beginning, and then it starts combining the closest pair of the clusters, that is the distance between the two data points, or we can say the two cluster, because it consider each data point as a single cluster. So this distance can be calculated using any distance calculating matrix. So using for example by using the Euclidean distance, we will calculate the distance between the two clusters, and the clusters that are close to each other will be merged together. So it does this until all the clusters are merged into a single cluster that contains all the data set. So this approach will combine all the clusters until a single big cluster is formed of all the data sets present in it. So let's understand this with an example. So step 1, consider each data point as a single cluster. Let's say there are n data points, so there will be so the number of clusters will be also n. As I told, this approach considers each data point as a single cluster. So in this graph you can see there are 6 data points. So the approach will consider each of this data point as a single cluster. Step 2, take two closest data points or clusters and merge them. So there will be now n minus 1 cluster. So Euclidean distance can be used to measure the distance between two nearest or two closest clusters, and accordingly we will merge them together. So in this graph, these 2 points or these two clusters were close to each other, so they are merged into a single cluster. Step 3, again two closest clusters and merge them. So now there will be n minus 2 clusters. Now in this step these 2 points were closer, so they are merged into a single cluster. Step 4, repeat this step 3 until only one cluster is left. As you can see here, after combining or merging these two clusters, this point was near to this cluster, so it is merged into a single cluster. In this figure, the third point, this point was nearer to the single cluster, so it is merged into one, and finally it is merged into a single cluster. Step 5, once all the clusters are combined into one big cluster, develop the dendrograms. So what are the dendrograms? We will see now. So dendrograms are nothing but they are a tree-like structure that is mainly used to store the each step performed by the hierarchical clustering algorithm. So in dendrogram, the y-axis represents the Euclidean distance that we have used to measure the distance between the two data points, and the nearer data points are merged into a single cluster, and the x-axis of dendrogram represents the data set or the data points present in the data set. So this is the dendrogram that we have drawn for the previous example. So as we have seen in the previous example, the points P2 and P3 were merged together into a single cluster as their distance were less. So the dendrogram is drawn for the respective one. So first P2 and P3 data points combine together and forms a cluster. Then corresponding dendrogram is created which connects the P2 and P3 with a rectangular shape. The height is decided according to the Euclidean distance between them. So as P2 and P3 were closest to each other, they were merged into a single cluster. So the first P2 and P3 data points or the clusters are merged together. So we have drawn a rectangular shape. So this the height of the rectangular shape represents the Euclidean distance between both the points. Then after combining P2 and P3 point, the next 2 points that were combined were the P5 and P6. So here you can see the rectangular shape for P5 and P6 have been drawn. The height of this rectangular shape is slightly higher than the previous one because the Euclidean distance is a bit greater than the previous one. So its height is larger, or we can say it is greater than the previous one. After combining P5 and P6, we have combined the points P5, P4 and P6 together, and then P2, P3 and P1 together. So we are combining the point P1 with P2 and P3 here. So you can see a dendrogram or a rectangular shape is drawn which represents the combination of point P1, P2 and P3, and similarly the point P4, P5, P6 are combined together and we have drawn the rectangular shape. And finally all the data points are merged together into a single big cluster. So here you can see the rectangular shape is drawn. So again it represents the Euclidean distance. So this is how we draw a dendrogram for the hierarchical clustering algorithm. And this was the bottom-up approach that we have used, and when we use bottom-up approach it is called as the agglomerative hierarchical clustering approach. So there are some advantages of using hierarchical clustering. As we know, there is no need to predetermine the number of clusters in advance as we did in the K-means. That is one of the advantage. Then hierarchical clustering is easy to implement. It has good visualization capability. On contrary, there are some disadvantages. In many cases it has cubic time complexity, so it is quite slow. It is not scalable, and it do not work well in the presence of noise and the outliers. So that was all about hierarchical clustering algorithm. Thank you.